As we move into 11.3, this is going to be broken into two parts. So you have two graphs. This first one here, notice that the line now is not proportional because it is not going through the origin, which would be right here. And you also have this one. It's also not going through the origin here. And there's two components that we're going to answer. We're going to complete each diagram so that all the vertical and horizontal segments have expressions for their lengths, and expressions can be written numerically or with variables, and you're going to find you'll do both here. And once you write those expressions, we're going to use our knowledge of similar triangles to focus on creating an equation. Now, equations can essentially be looked at as like a rule, and we did that earlier in this video, right? This was our rule or our equation from earlier. But now the difference is we don't have a proportional relationship. It's actually translated now. If you look at this triangle, it actually has been shifted up one. I'll put translated actually. Whoops. Translated up 1 unit. Okay, and that's an important piece to make sure you note because it's going to change the dynamic this time. So feel free, pause, try it. It might be a little challenging and that's okay, but I encourage you to pause and try this because it'll give you a deeper understanding when you come back after you've had some time to think about it, digest it, and look at it. Welcome back if you paused. If you didn't pause, thanks for still listening. Okay, so I'm going to go through and highlight because I find it helpful to identify those side lengths. So I have I'm going to use this to write vertical side. Or vertical distance. And I'm also going to go in and just take care of this really quick. And I'm going to highlight my horizontal distances. And we'll say horizontal distances. Okay? Or lengths or whatever you want to call them. So we have to start by writing these expressions. And so as we think about the bigger triangle here, ABC, it's already filled in with a 3 and a 4. But the expressions we want to come up with are how do we get 3 and 4? Because it's going to help us in deciding the expressions for the smaller triangle. Well, I know that I have to represent the side length, and obviously I can count and know that it's 3. But if they took this grid away and all I had were the points, I know that this point is 8, 7. I also know that this point here is 8, 4. They have an 8 in common, right? My x value is the same. So actually, I'm going to write it like this. I know that the x value is always 8 and the y value is what's changing. So you can see that. I'll actually go in and highlight it. I think that'll be helpful. My y value, my y value, my y value, but the 8s all stayed the same. So I'm really getting that numerical value of 3 by taking 7 minus 3. It's that vertical line. So now let's compare that to the smaller triangle because for the smaller triangle, E is represented by XY. F they don't even give you anything for F, but I can make some inferences based on what I have. I know based on what I just did in this first piece, all of the X values have to be the same. And since I don't know the X value for F, I'm going to leave it as just X. And my Y value, I actually can identify here because it's on the line of 1. So I'm going to put X is at 1 for Y. And now let's think about what expression would I have to create to actually find that vertical distance. Well, if I knew the Y value, if I knew what this was, I would have to take away 1. I would have to subtract 1 from it. And let's put that into perspective. I'm going to erase my question marks. Oops, didn't mean to erase all of that. Didn't mean to do that again. We'll just leave that one there. Okay, so if I knew the y value, I would have to subtract 1 from it to get that distance. Well, let's think about it though. This line is not starting at the origin. It is shifted up 1. If this line started at the origin, I wouldn't have to take 1 away because I would be able to just count numerically whatever that y value is. And I would say, oh, it just goes up to this point. But because the whole line shifted up 1, I have to consider that difference. So we're going to represent that expression as y minus 1. Okay, let's go into the horizontal side now. So for my horizontal side, I'm going to label the points again. I don't have A listed, but A would be 4, 4. And what expression would I write to represent the side length that is labeled 4? Well, now notice this. Now I have 4, let me take the black pen, is the same in both of them, which is the y value, and it's the x value that's different. So I have 4, and then I have 8. So an expression to get to 4 would be, I would subtract 8 minus 4, right? I know here is 8, I know here is 4, and to find that measurement, I do 8, and I subtract 4, and I have that horizontal distance. But now let's go to the small triangle and see if we could put that into perspective. We've actually already labeled F as x1, but the triangle did not get shifted over this way at all. So I really don't have to consider any other distances other than the fact is if I knew what this point was, that would essentially be the side length of the triangle. So I'm going to just call that x, because I'm not really subtracting anything from it because it's not shifted over to the right. Now, if we put that in comparison to the bigger triangle, let me take a different color here. Let's take pink. Let's say I was going to focus on this side length without any information. Well, I know that if I'm trying to find this distance out, this triangle was actually shifted over 4 units. So that is why I'm subtracting 4 units, is because the bigger triangle was moved over 4 units. My smaller triangle was not, so I can just call that x. If you didn't quite understand what I meant just there, hang tight because that's going to come into play in the second graph. Okay, so let's talk about these expressions. I know there's getting to be a lot of components written down. I'll use orange. This, oh, that looks to be the exact same color. I'll use blue. This here and this here that I already had. Those are my expressions for the small triangle. So what is the slope of this triangle? Well, if I go back here and I look at this triangle with the side lengths of 3 and 4, my vertical distance is 3, my horizontal distance is 4. That is my slope. That means every slope triangle I create should have the same slope of 3 over 4. So with my expressions, y minus 1 and x, those represent my vertical distance and my horizontal distance. But every vertical and horizontal distance has to equal 3 over 4. So this is now my new rule. Any point that I take, right, in the previous one, let me scroll back up, I could just take the ordered pair and say y over x is equal to the slope. But now I have to consider that the line has been translated up 1 unit. So because it's been translated up 1 unit, my slope triangle essentially is up 1 unit. I have to subtract 1 from that y value to take into consideration. My x value didn't need to do that. Any point I use should give me 3 over 4 if I use this rule. So let's try it out. Let's take a point. Let's try B. We said B was 8, 7. Well, if I use this formula I created, this rule, I should get 3 over 4 without having to make a slope triangle. So 8, 7. My y value is 7, so I know I have to subtract 1 from it. And my x value is 8. 7 minus 1 is 6. 6 over 8 is equal to 3 over 4. That proves it. Let's take point A and try it. Point A is, this was B. Point A is 4, 4. if I use this same rule here, 4 minus 1, and the x value is 4. 4 minus 1 is 3, and x stayed as 4. That works. Let's pick a point that's not on the line, just for fun. This point here, we'll call it P, is 10, 2. What we should see happen is that it won't work if we use this rule. So here's point P, 10, 2. My x and my y value. My y value is 2, and if I take 1 away, I keep my x value 10, I end up with 1 over 10. That is not equal to the slope. So if we can create these equations, we can test points to see, will it fall on the line when our grid is not big enough to actually see if it falls on the line. Okay, I'm going to actually stop the video here, give you a little breather, digest it, and you'll get another video for part 2.